Okay, so we've already talked about transformations. What's another name for a translation? What's another name for a translation? Slide. We've already talked about reflecting, where we're going to flip things over a particular line. And now today we're going to talk about rotating. Okay? Now, when you rotate things, you have to have a point that you're rotating around. Okay? That's kind of a big idea here. So, get into the definition of rotation. A rotation is a transformation in which a figure is turned about a fixed point. Okay? So, for example, in just a general sense, if I have, let's say I've got this shape, let's just make it a little diamond here. If I have a diamond, okay, and I'm going to rotate that, I need to have a point that I'm rotating around. Now that point could be where I drew it here. That point could be, maybe it's that point right there. Okay? It all depends where the point is. Okay? So let's just, for this example, say that the point of rotation is right here. Okay? So if I'm going to rotate this, I'll just say this. In this class, we will always rotate it counterclockwise. Okay? So if you look at the top, we're going to the left. Everything we do is going to be a counterclockwise rotation. So if I'm going to rotate this a certain amount of degrees to the left, in this case counterclockwise, well, this point, if I make a dotted line, needs to rotate the number of degrees that I'm talking about. Okay? Our angle of rotation. So if I just call this theta, raise your hand if you've seen that before. Okay? This is a letter of the Greek alphabet called theta. That is oftentimes used in math to represent an angle measure. Okay? Hopefully we'll see more of that as we get going. That just means, hey, there's some type of angle there that we're not identifying. Okay? So if I'm going to move this, if you want to put a little arrow there and say angle of rotation, maybe you want to put an arrow there that says point of rotation. Okay, so if we're going to rotate that, then this diamond would look something along these lines. Just to give you a general idea. I've rotated it. It's probably not the best example. Probably is getting a little bit close. The thing that we need to understand here is that the distance away from the figure, from the pre-image to the point of rotation, is the same distance from the image to the point of rotation. Okay, they're the same distance away. Has the shape changed size or shape? No, so it's an isometry, rigid motion. It hasn't changed. Okay, now in this class, what we're doing is we're going to be rotating 90 degrees, 180 degrees, and 270 degrees counter rotation, or counterclockwise.
I need to talk to go to my office, please.
Taylor, you need to go to, Nevaeh's absent. 90 degrees, 180 degrees, I take all your stuff. 90 degrees, 180 degrees, or 270 degrees counterclockwise. Okay, so I want you to think about this. 90 degrees, let's pick a point. Let's do the point 1, 3. I think we did that the other day, didn't we? When we talked about reflections. I want to think about rotating the point 1, 3. I'm going to put that right there. Here's what I need everyone to do. I want you, and my point keeps disappearing on me. I want you to put your pencil at the origin. Where's the origin? 0, 0. Put your pencil at the origin. Okay? Now, I want you to rotate your paper counterclockwise 90 degrees. Everyone watch me. Everyone watch me. I'm going to stick my pencil at the origin, and I'm going to rotate the paper 90 degrees so it sits like this. That's essentially what we did. Now, the point that we just moved, what are the coordinates of that point? If we rotate it, that point we're calling A prime. We're calling A prime. That's over here at -3, 1. So that's A. And this is, gosh darn, this is bad today. A prime. Man, why are they disappearing on me? Now, has that moved 90 degrees? And here's how we can check. Okay, here's just maybe a little easy way to check. And if I were to make, our point of rotation is always going to be around the origin. Okay, that's the only point we're going to do. But if I were to make a dotted line or a line from point A, which is our pre-image, to the origin, and then from the origin to our image, what kind of angle did I just make there? 90-degree angle. Okay, so that would be a 90-degree rotation. Now, what do we notice? What do we notice about how we got from the coordinates of A to the coordinates of A prime? We've switched them. We've switched their locations. So instead of AB, it's going to become BA. And then we change the sign of the new what value? Of the new X value. So we've changed the sign, flipped the sign of our new X value.
I have a question. How did you get the negative? I don't see a negative on the
So there's not on the A. A is the point 1,3, but after we spun our paper, this is the point -3, 1. Correct. So our rule of thumb, to make a 90-degree rotation, counterclockwise, and they're always going to be counterclockwise, is to switch X and Y and make the new X, flip the sign of the new X. Maybe you want to put that right here. Put a little star there. Flip sign of new X value. We're going to flip the sign of the new X. Obviously, we have to switch X and Y, but then flip the sign. Any questions about that? Okay, now, same point. I'm going to use the point 1,3. I'm going to call that point A again. So A is 1,3. Now, here's what I want you to do. Plot 1,3. I want you to put your pencil at the origin and then rotate your paper 180 degrees. 180 degrees. So if I do that, if I put my pencil at the origin and I rotate 180 degrees, what are the coordinates of A prime? Kira? -1, -3. Do we agree with Kira there? So -1, -3, that would be A prime. Again, a way to check ourselves is to do this. If I go from the point, you don't have to do this, but this is a way to check. If I go from A, our pre-image, to the point of rotation, which is our origin, then from the origin to our image, did that make a 180-degree turn? Yeah, 180 degrees is a straight line. So what happened to our coordinates? Did we switch their locations? No, we didn't. We just switched our signs. So it's going to become the opposite of A and the opposite of B. You want to put there? Well, just flip the signs. 180 degrees, we're going to flip our signs. Okay, same idea. I'm going to use the point 1, 3. We're going to do 270 degrees. Now, guys, 270 degrees counterclockwise is like, how many degrees clockwise? 90. Okay, so you could do 270 degrees counterclockwise, or you could do 90 degrees clockwise. They're the same thing. What are those coordinates, guys? 3, -1. 3, -1 is A prime. So what happened to our coordinates there? We switched them, right? We switched them to make that B and A, and then we made the new Y value the opposite sign. So we're going to switch X and Y, and then make, or I'll say flip, it's a bad flip, flip sign of new Y value. Questions here? Those are our 3 rotations that we're going to be doing today. Okay, here we go. A, B, C, D. Go ahead and plot those first, please. I guess that's ABC, not ABCD. Okay, so 90 degrees about the origin. What's our rule again for 90 degrees? Let's go back up to the top of our notes and take a peek. We need to, it just went back down, what is it? Switch X and Y and make the new X, or flip the sign of the new X, okay? So here's what I'm going to do. I'm going to flip these. So I'm going to make it 2, 4, but then I got to flip the sign of my new X value. This is going to become 5, 6, then it becomes -5, 6. This is going to become 4, 1, so it becomes -4, 1. Switch our X and Y, make our new X the opposite sign. So let's plot those. If I go -2, 4, that's A prime. Go -5, 1. Oop, that's wrong. -5, 6. -5, 2, 4, 6. There we go. There's B prime. And C prime is -4, 1. Of the 3 that we've done so far, as far as translation, reflection, rotation. I think rotations are the hardest because they're the most difficult to visualize. Okay? And I say this at the end, when you're all done, okay? When you're all done, put your pencil at the origin, okay? And take a look at our original one and our ending one, our pre-image and our image, okay? And if I rotate this paper 90 degrees counterclockwise, the red one now should look like the blue one when we're done. The pre-image should look like the image when we're done, after we rotate it. Okay? And again, you don't have to do this, but if I were to take, a line from A back to the origin and then from the origin to A prime, well, there's 90 degrees. If I would do B to the origin and then B to B prime, that's 90 degrees. C to the origin, or the origin to C prime, those are 90 degrees. Every point rotated 90 degrees counterclockwise. Every vertice there. Let me erase some of that because that got kind of ugly. Uh-oh. Okay, questions or concerns there? Let's go to this next one. Go ahead and plot those, please. Alrighty, now we're rotating at 270 degrees counterclockwise, which is the same as 90 degrees clockwise. So I'm going to write all my vertices out again. Now what's our rule again for 270 degrees rotation? Switch X and Y, and then flip the sign of the new Y value, okay? So D, that's going to become 1, 3, but then I need to flip the sign of the new Y value. E, that's going to be 1, 5, but I need to flip the sign of the new Y value. F prime, this is going to be -3, 5, but then I need to switch the sign of the new Y value. And lastly, -1, 2, but then switch the sign of the new Y value. Okay, let's plot all those. I've got 1, -3 for D prime. I've got 1, -5 for E prime. I have -3, -5. I did? Oh, 1, -3. Thank you. 1, -3. Do we agree there? So that is D prime. Okay, I like that, as long as it doesn't go away on me. -3, -5. And then lastly, G is -1, -2. Has it changed size or shape? No, it has not. Rotated 90 degrees. Another way, like I said, the hardest part about this is it's harder to visualize. But I think of rotations kind of like boats or ships. Think about a big ship, they can't just turn around on a dime, can they? They've got to make big arcing turns. So if you think about this being a ship and point F being the front of the ship, okay, and they're going to make a 90-degree turn, well, that front of the ship now is going to be facing that direction, F prime. So think about turning a boat or a ship. Okay, moving on here. Top of the next page. Guys, we're going to come across some compositions where now we're going to be maybe rotating and then reflecting, or translating then rotating, and a mixture of them. So here we need to first reflect and then we need to rotate. Okay, so we've got a couple things here. Let's go ahead and plot. It's just a segment here, pretty simple, RS. So R is 1, -3. And S is 2, -6. Did I plot that one right? Okay, now the first thing we need to do is to reflect it over the x-axis. X-axis is this way, okay? Now when I reflect over something that is either horizontal or vertical, I know that R is 1, 2, 3 units away from the x-axis, so I'm going to end up 1, 2, 3 units away above. That would be R prime. And then S is 6 units below, right? So it needs to be 6 units above. And there's S prime. Questions there? Okay? So now I need to rotate the blue one. Okay? R prime, S prime. Now, just to make sure, what are the coordinates of R prime? Because when we rotate it, we're going to have to switch the coordinates of R prime and S prime, not R and S. So R is now 1, 3, and S prime, R prime is, S prime is 2, 6. Is that right? So now those are the coordinates that I'm going to be changing. Okay, so R double prime and S double prime. So we're doing 90 degrees. What's our rule there again? Switch them and flip the new X. So R prime, our double prime, I should say, is going to become 3, 1, but then I need to make that a -3. And then S prime, double prime is going to become 6, 2, but make that a -6. So R double prime, -3, 1. And S prime is -6, 2. So we start with the red one. We reflected it in the x-axis, over the x-axis, and then from there we rotated it 90 degrees about the origin. Questions there? Okay. Last thing here is talking about rotational symmetry. Okay. We've talked about line of symmetry in reflecting things. Well, now rotational symmetry. So rotational symmetry is a figure is mapped onto itself by rotating it 180 degrees or less. Okay, so for example, we've got this, whatever, maybe it's a fan or a boat propeller, but here is the image, and if I rotated it 45 degrees, is it mapped onto itself? I mean, does it look the same way that it started? No, but as I get to 90 degrees, it does, doesn't it? 0 degrees and 90 degrees essentially look the same, and 0 degrees, 90 degrees, and 180 degrees all look the same. So that would have rotational symmetry at 90 degrees and 180 degrees. Okay, so the instructions here say, does the figure have rotational symmetry? If so, describe any rotations that map the figure onto itself. Okay, so if I look at this shape right here, and let's say in rotational symmetry is all about the The point of rotation being in the center. Does that have rotational symmetry? And if so, at what degree measure does it? And you can literally put your pencil in the middle of the shape and think about rotating your paper and figure out when does it look the same as it does when it started. One thing that can be helpful as well is draw the diagonals. Like so. And think, okay, we have two different sizes of diagonals, don't we? So how much do I have to turn to make the long diagonal be slanted in the same direction? How many degrees? 360, but again, that doesn't have rotational symmetry. We're just talking about 180 degrees or less. Elizabeth? Doesn't it have rotational symmetry at 180? Everyone draw the diagonal in there, and it's slanted from left to right, going up. And I want everyone to rotate their paper 180 degrees, and you'll see it's got the exact same, figure. It's mapped to itself if we rotate it 180 degrees. So this answer is yes. And it's 180 degrees. Okay, what kind of shape do we have here? That's an octagon, okay? So, I want everyone to do this for me. Draw all the diagonals in. Is this going to have rotational symmetry? It is, and I think that's easy to see. The harder part is figuring out, okay, how many degrees do I need to turn it? Okay, and here's how we do that. How many degrees are in a circle? 360. So if I go all the way around that thing, there are 360 degrees. Okay, now, would you guys agree with me that I have a bunch of congruent triangles in there? So if I look at the inside angle of all these triangles, that would be the same angle. Okay, so how many triangles are there? I think there's 8 of them. There's 8 triangles. So take 360 divided by 8. What do we get? 360 divided by 8. It's 45. Thanks for those of you that have a calculator and actually did that. 45 degrees. Here's what that tells me. Each interior angle here, and I can't demonstrate this very well because the picture is so small, is 45 degrees, which means to turn the shape so it looks exactly like it does, it needs to be 45-degree turn. So does it have rotational symmetry? Absolutely it does. It's going to have rotational symmetry at 45 degrees. Now, if it has rotational symmetry at 45 degrees, isn't it also going to have rotational symmetry at 90? Basically, we turn it 2 of those. So it's going to have rotational symmetry at 90. If it's got rotational symmetry at 45 and 90, isn't it going to have rotational symmetry at 135? Because that's just another turn. If it's got rotational symmetry at 45 and 90 and 135, then it's going to have rotational symmetry at 180. Okay, so it does yes 4 times. Is everyone okay how we took took that shape and divided it amongst 8, because there's 8 equal sides there. Okay, and lastly over here, is that thing gonna have rotational symmetry? It's not. It would have to go all the way around to 360 to get there, and that's not considered rotational symmetry, so this would be a no.